2x times x squared plus 7. The whole idea of a U-substitution is I have those 20 formulas
Yeah.
that I know. Those are the only integrals I can do, right? So I have to write this integral in terms of one of those. I can try to do that by writing it with like a different letter. And I'm going to say that this letter is x squared plus 7 because I don't know, it's maybe a good idea. Oftentimes, it makes sense to make u equal to something that's like inside of something else.
Yeah.
So like this is literally inside a parenthesis. So that might be a good idea. Okay, so then you have to compute like the differentials. You basically do a derivative. So if you did the derivative of this, it would be 2x. And
Yeah.
then, so my goal is I want to replace the dx with
Mm-hmm.
something involving du. That's why I'm doing this, right? I'm trying to rewrite this integral entirely in terms of u, and then hopefully it will look like one of the 18 formulas I know. So I would normally solve for dx here so that I could plug it in. You know how you would solve for dx here? You can sort of treat this like it's a fraction, right? The du dx, you can treat it like it's a fraction, although it's not technically a fraction.
Would I just treat it like algebraically in terms of this one?
Sure, yeah.
I'd multiply dx with a 2x and then, yeah.
Okay,
Yeah. And then I would do du over tx. I mean, 2x.
exactly. Du over 2x equals dx. So now let's plug in to our integral. So x squared plus 7, that is u because we say so. And then dx, that is du over 2x, right?
Mm-hmm.
Oh, look at this.
Oh, yeah. It's
It
cancels out.
cancels. That's convenient. So we end up with the integral of u du. Oh yeah, I know how to integrate that. That's one of those formulas that I know. So x to the n dx, if you're integrating it, is x to the m plus 1 over m plus 1 plus c, right? So
Yeah.
in this case, and notice that in this case, by the way, this actually is really important to point out. This is an x, this is a u. They're different letters. It
Yeah.
doesn't matter though. Well, the only thing that matters is that the letter here and the letter here are the same. They have to be the same.
Okay.
And then, whatever letter that is, then that ends up being the letter here, right? It's like all these
Yeah.
letters always match up, and here
Okay.
U's matching up, so that's good, right? But
Hmm.
those have to match up. So if you instead have like the integral of U dx, that wouldn't work.
Oh,
They
okay.
don't match up. Anyway, so what do you think the integral of this is going to be?
Okay. Then there would be a u to the power of 2 over 2.
Yeah, exactly, exactly. So we're working with U's here. The question was originally written with X's though. So yeah,
Yeah.
we should probably plug the X's back in. So if we plugged in the X's now, we would get x squared plus 7 squared over 2 plus c. And then this would be the answer. Yeah, this is the
Oh,
answer.
okay.
So we do want to plug in the x's again, but we want to do
Yeah.
that after we integrate. The whole reason why we wrote it in terms of u was so that we could actually integrate it. If you plug in the x's before you integrate it, then you're not
Oh,
going to be
okay.
able to get the integral.
So like when you're doing your integrations, like it's usually just in terms of the u, and at the end you plug in what like u was supposed to be.
Yeah, yeah. And yeah, and the
Oh,
whole
okay.
reason why we have to use this like variable during the problem is because it actually puts the integral in a form that we can actually work with.
Yeah.
Right? It writes the integral in terms of an integral we know. And you could, if you want to, you can always check your results by finding the derivative of your result.